Hello everyone. In this section, we're going to learn about power functions. So we're going to talk about what they are, how they're manipulated, which is going to lead into talking about different kinds of exponents and like what are fractional exponents, what are negative exponents. We're going to talk about categorizing functions as even or odd, what that means, how we know what is what. Let's see, we're going to determine the degree of power functions, which we touched on in the last section, the exponential function section. So we're going to talk about that more. We're going to talk about which function dominates over time, what that means, and how you know, and then some modeling. So let's talk vocab. Power function. A power function is a function where y equals k times x to the n, where k and n are any real constant numbers. So an example of this is y equals, let's see, y equals 3x cubed, or x to the fifth power, or x squared. As long as this k, this constant right here, and this exponent are real numbers, then it's a power function, and that's the only term. Now we have the zero power. The zero exponent rule is anything to the zero power equals 1 if this a is not 0. So this means like 2 to the 0 power equals 1. And I'm actually just going to talk about why that is because that seems kind of strange, right? So if you remember exponent rules, and we can prove this by writing exponents as repeated multiplication. But let's say you have like 2 to the fifth over 2 to the third. This is 2 to the 5 minus 3, which is 2 squared. So now let's do this. What if these exponents are the same? What if this is just 2 over 2? So this is 2 to the first power over 2 to the first power. We know that 2 over 2 is, a whole over a whole, so is 1. But if we apply that exponent rule, this is also equal to, if we fly this over here, 2 to the 1 over 2 to the 1 is also 2 to the 1 minus 1, which equals 2 to the 0. So that means 2 to the 0 is also 1. And this just has to do with the inverse of multiplication and division. So hope this little proof makes a little bit of sense. So now we're going to talk negative to the negative power. So a negative exponent means how many times to divide by that number. For example, 8 to the negative first power is the same thing as 1 divided by 8, which is a fraction 1/8, which is 0.125. Another example, let's do 4 to the negative 2 power is the same thing as 1 over 4 squared, which is 1 over 16. Fractional power. So a fractional exponent is an alternate notion for expressing powers and roots together. For example, let's do 2. Base 2 is always nice. 2 to the... Okay, we'll just do to the 3 halves. Yeah. This is the same thing as saying, okay, 2 cubed, and then square root that, because remember that anything to the 1/2 power is really square root. And that goes the same for cube root or anything higher. So this 2... Actually, we're going to do a better example. We're going to change that 2 to a 4. Okay, so now 4 to the 3 halves power. You can do 4 cubed and then take the square root of that, or you can take the square root first. You can deal with this 2 in the denominator first. So I can take... So what I'm really going to end up doing is do 4 to the 1/2 power and then cube it. And that's all okay to do. You can break this apart. So that means 4 to the 1/2, square root of 4 is 2, and then 2 cubed is 8. So if you know your rules, a lot of times you can find fractional exponents pretty quickly. If you understand that you can like square root before you cube it, so take the denominator before you cube something. Yes. All right, now let's keep going. I'm going to go ahead and clear this. Okay, let's talk about even functions, odd functions, dominant functions. So an even function visually is if it's symmetric with respect to the y-axis, so it's the same like this way to this way. So we flip it over that y-axis. Algebraically, so here, actually symmetric, that's like your x squared function. Some functions look, oops. Some functions look like w's. So you might end up with functions like this. These are all symmetric across the y-axis. If they cross the y-axis, so they are called even functions. Algebraically, a function f is even if and only if f of negative x equals f of x, which just means that if you plug in a positive number for x, you'll get the same number if you plug in a negative number for it. So it's even across the y. Odd functions, on the other hand, are symmetric about the origin. So that'll be like your x cubed functions like that. And algebraically, a function is odd. Oh, I wrote if. IFF means if and only if. That's what up here is. All right. So a function f is odd if and only if f of negative x equals negative f of x. So for example, if I plug in like 3 and I get a value up here, if I plug in negative 3, I should get the same value, just negative. And that's what it means to be symmetric about the origin. In other words, it's called an odd function. Okay, dominant functions. This went on to the second page. Okay, I'll fix that so yours doesn't go onto the second page. So, dominant functions, to put it like purely visually, is as the function approaches infinity, so as it goes right forever and ever, as x approaches infinity, the dominant function will rise steeper. So it'll like increase its y values at a faster rate than a different function. And a lot of times to be able to see this, you have to zoom out very far. So we're going to get very familiar with the ranges in Desmos for this one. So in other words, so this is a definition that doesn't use any limits. Limits is going to be one of the very first things that we talk about in calculus once we like pass all of these like base knowledge things. Limits is one of the key ideas, and this dominant function actually deals with limits. So this is kind of an introduction to that without using that definition, without using the definition of limits. So in other words, if you have like a combination of functions, so say you have like x times e to the x, the dominant function is what that function will end up looking like as you zoom out and out and out. And on the right-hand side, we have some general rules. So like exponential functions will dominate polynomials. Polynomials will dominate logarithms. And then here is some other rules. Among exponentials, larger bases dominate smaller bases. So like 3 to the x will dominate 2 to the x. And then among polynomials, higher powers dominate lower powers. So like x to the 12th will dominate x to the 10th power. Yep. And that's that. We'll talk more about this as the notes go on. So there's just a basic definition here. And we'll talk about what this looks like. We'll graph things in Desmos. And that's it for vocab and introduction. So email me if you have any questions at all.